Good morning, my YouTube viewers. It's Crystal here. Yesterday, I made a video and I showed you how to create a CSV file using only Python. But basically, Python and its inbuilt modules. But I didn't really like that CSV file because you couldn't win. Because the values for company A and company B were always going to be similar. So I made another CSV file using pandas and numpy. So that means that you would have to import pandas and numpy. And what I'm going to do in this CSV file is show you how to make it, and then you can do a hypothesis test using this CSV file. So this is a CSV file of 100 rows of sales data for 2 companies. Okay, and so I worked on this yesterday. So the first thing that you do is you're going to set your random seed to 0, or you can set the seed to any number that you want. You're going to set up your dates equals pd.date range start 2025-0101 for 100 days, and the frequency is going to be days. And you could change the frequency to weeks or months or maybe even years if you would like, but this particular CSV file is in days. So you've got sales company A, you create random NP random randint for from 50 to 200 in a size of 100, and then you have sales company B, NP random.randint from 70 to 250, a size of 100, and the difference is going to be the sales company A minus sales company B. And then I had a difference, so because the difference allows you to go ahead and do a paired t-test. So we create our data frame using pandas. df sales equals pd.data frame. Date is dates. Company A is sales company A. Company B is sales company B. And difference is difference. And then we're going to save the CSV file. df sales to CSV sales data.csv. And then we're going to print CSV file has been created successfully. So we've created our CSV file. So now that we've created our CSV file, we're going to do the t-test, the paired sample t-test. And okay, so in order to do the paired t-test, we need to import some libraries. So you're going to import numpy to perform your numerical computations, pandas to create the data frame, scipy to perform the scientific calculations, and matplotlib to visualize the data. So we're going to load the CSV file that we just created. df equals pd read CSV, and we're going to print it. And this is what it looks like when we print it. We're going to calculate the mean difference, the difference between the two means. But I didn't get that. I can say, So I can print it. I'm not going to print it. Well, I can print it. I'll show you how to do it. First thing you have to do is you have to create the data set all over again. So we're creating the data set all over again. So the data set will come up in a little bit. Sales status CSV. And then I'll create the main then we run this a second time. So I got an error somewhere. Try it again. So we've got a mean difference of -14.04. So that's not very much, but I did my best. So the mean difference is -14.04. And then we're going to calculate the standard deviation of the difference. STD diff equals NP STD diff difference DDOF equals 1. And DDOF is degree of freedom. And let's try that. STD difference is 62.27. And then we calculate the standard error of the mean difference. Standard error equals STD diff over NP square root the length of the DF. So you print your standard error. And the standard error is 6.22. Then we calculate the degree of freedom. Degree of freedom equals the length of the data frame minus 1 So that should be 99. So it should be 100 minus 1 is 99. Let's see. So we're going to print the degree of freedom, see how we get on. Degree of freedom is 99, which I previously said it was 99. Now we perform a critical t-value for a 95% confidence level. So your alpha is 0.05, and that's your confidence level. So it should be 0.05 confidence level. And so your critical T is stats.t ppf. ppf stands for percentage point function over 1 minus alpha divided by 2 DOF. And it's going to be you print your critical T value. Critical T value is 1.98. And then we're going to perform the paired t-test. Okay, the difference between a paired t-test and a two-sample test is a paired t-test. It's the pairs are related to each other. And so normally you would do a paired t-test like if you were doing testing results before the test and then the results after a certain modification to the test. But since both of these, Company A and Company B, since they're both based on 100 days of data, you can do a paired t-test. You could do a paired t-test or a two-sample test, but in this instance, we're doing a paired t-test. And so t-stat, p-value equals stats.t-test rel. Rel means related, I believe. And then so it's going to be DF Company A, DF Company B. Then you print your t-statistic, and then you print your p-value. So your t-statistic is negative 2.25, and your p-value is 0.02. So we'll go ahead and carry on with it before we analyze it. So we print the results, and then so we printed all of these results, the degrees of freedom. So we've got the degree of freedom twice. So I don't think I need to put the degree of freedom in here because we've got it twice. We don't need to duplicate our work. And then what we're going to do is we've got code in here so we can plot the code in here so we can plot our results on a graph so you can see the results. So you can see the t distribution, you can see the rejection region, you can see your t statistic is negative 2.25, and then your neg critical t is negative 1.98, and your positive critical t is 198. So you can see the t statistic is in the rejection region, which means that you have to reject the null hypothesis because the t statistic goes further than the t critical. But it's just nice to have a diagram so you can see how it works. And then so we've got here salary distribution of employees in company A and company B, and that's not working out the way I wanted it to work out. So but I don't think I can do that. The reason why is because I don't have company A and company B in there. And since I don't have company A and company B in there, there's not really much point in keeping that in there because I don't have company A and company B in there. So I'm just going to delete it and run it again. So you can see we've got our t statistic, we've got our diagram of the t distribution, and the t statistic is in the rejection region. But what we can do now is this is a simple two-sample test. And when we perform the two-sample test, the two-sample test is different from the paired sample test. And the reason why is because in the two-sample test, you calculate the mean and the standard deviation and the length in company A and company B. And you don't do a paired test, you just do it separately. And you can calculate your degree of freedom. And I looked on the internet because I took all of this code and then I put it in Excel as well, although I'm not going to make a video on it at this point. But the degree of freedom for what I put on Excel was different from the degree of freedom that you would have had in Python. So I looked on the internet, and the internet said that a degree of freedom can be NA plus NB minus 2, which would be 98. So no, not 198, because it would be 100 plus 100 minus 2 is 198. So I just used that degree of freedom because it was simpler. And we want to keep everything simple, and you can see the degree of freedom here is 198. And then we used exactly the same methodology, except for we used the code for a two-sample test, a code for the p-value, and for the t-critical, and the t-statistic, which the code for the t-statistic is simpler on the two-sample test than it is the paired mean test. So for the t-statistic, it's mean A minus mean B divided by standard error. And then calculate the degree of freedom is simpler. I used a simple diagram for that, a simple formula for that. And then to calculate the p-value is stats.t.sf, and SF means survival function. It equals NP, absolute value, ABS, t statistic, comma, degree of freedom, times 2 for a two-tailed test. And then we do our conclusion. So if the t statistic is greater than the t-critical, then you reject the null hypothesis. Otherwise, you're going to accept the null hypothesis. And so what I did was I used Matplotlib. I printed off the data frame and all my values and the t-statistic, and you've got your t-distribution, so you can say that your t-statistic is 2.25 negative, T critical is negative 1.98, which is in the rejection region. So that means you have to reject the null hypothesis. But what I want to see on this one is the T statistic and the critical value is exactly the same in the two types of programs, which it shouldn't be, but it is. And then what I did was I plotted the means of company A and company B. So you can see the mean of company A is 130.15 and the mean of company B is 144.19, which gives you a difference of about 14. So there's two ways that you can calculate the values of sales data for two companies using either a paired sample t-test or a two-sample t-test. And one thing that I forgot to mention in the paired sample t-test is I forgot to mention the conclusion. So in the paired sample t-test, if the absolute value of t-stat is greater than t-critical, then you have to reject the null hypothesis. Otherwise, you accept the null hypothesis. And so you can see the diagram here that your T statistic is within the rejection region. So you have to reject the null hypothesis. And I did spend a lot of time working on this last night because I was trying to get it so one of them would accept it and one of them would reject it. But it didn't work out that way, and I tried really hard to do that. And one thing that I've noticed that even though the calculations are different, the T statistic and the T critical is the same for the paired sample t-test and the two-sample t-test, I believe. Yep, it's exactly the same. And I tried my best. I tried my best yesterday doing lots of different values to actually get it different. So one would accept and the other one would reject, but it didn't work out that way. But since I worked so hard on this, what I wanted to do was go ahead and make a video on it and put it on the internet. So here you can see how it works, how you can make your own data frame to make your own data and then do hypothesis tests on that data as well, just for experimentation purposes. So thank you so much for watching my video. If you like my video, please like and subscribe. And I look forward to making more videos for you soon in the very near future.